Let's talk about Washer's method type 2. So in type 2, we have a vertical revolution axis and the integral is a dy integral. We have a function x equals to y squared that is a sideways parabola and x equals to 2y that is a straight line, and then we rotate the area about the y-axis. Again, if you want to graph functions like x equals to some y, you can use a free app called Decimal. It is available online. You can do it on your computer, your iPad, or your iPhone. The app is completely free. All right. So we have a curve, we have a straight line rotate about the y-axis. So since the y-axis is a vertical, we have a vertical revolution axis, and therefore that is a dy integral. And if you look at the area bounded by the straight line and the curve, you have to find the lower limit and the upper limit. That is easy. You set the two functions equal. You have y squared equals to let's do that. You have y squared equals to 2y, and then y squared minus 2y equals to 0. Factor out the y minus 2 equals to 0. So you have y equals to 0 and y equals to 2. So we have a 0, and at that point, y is equals to 2. So we know that the integral goes from y equals to 0 to y equals to 2. Okay, and then the next thing that we will have to do is we will have to find the area. How do you find the area? You use the right curve minus the left curve, right? So using this concept, we can draw a line like this. So we have a point touching the left curve, we have a point touching the right curve, and then we draw a straight line, right? So that is for the area. But this is a Washer's method. Hey, by the way, how do you know this is a Washer's method? The problem is not going to say, hey, this is a Washer's method problem. The problem will just give you a couple function, you graph that, and then you do all the works by yourself. They don't even give you the graph. You have to do everything by yourself. How do you know this is a Washer's method? Let me answer that question right now. So do you see that there is a spinning arrow, spin about the x-axis, and then there is a piece of area. So after you finish the spinning, just picture this in your mind. Look at the picture. Picture this in your mind. It is very easy. Do we agree that we have some space right here after you finish the spinning? So the object, the inside of the 3D object, the object is not solid, right? Because since there are some space, so you have some space inside the object. Compare this to the disk method. So if you go back to your disk method problem, after you spin the area, there is no space inside the 3D object. Let me say this again. For Washer's method, after the spin, there are some space inside the 3D object. For the disk method, after the spin, there is no space inside the 3D objects. That's the difference. All right, so since there are some space, let's just get rid of those little space. So since this is a different method, then for the Washer's method, you will have to consider the outer radius and the inner radius. Y. So here is y. So let's say we have a circle, we have a smaller circle, and then we have a bigger circle, like this. Now, what I wanted to do is I want to find the area of this space, the area of this green space. How? First of all, from the center to here, you have an outer radius, big R. And then for the inner circle, from the center to the edge, you have a small r. So to find the area, here is what you have to do. You have to do pi big R square, and then you have to minus pi little r square. So the concept is you have to find the entire area first, the entire circle, that is using the big R. And then you find the radius of the smaller circle. And then you take the big circle, scoop out the area of the smaller circle, then you get the green region. So that's why we have to think about the outer radius and the inner radius. If you look at the revolution axis on the y-axis, right here, on the y-axis, right there, do we agree that there is some space between the revolution axis and the dots, right? So therefore, we have to figure out the outer and inner. So what is the inner radius? the inner radius is asking which point is closer to the revolution axis. Can you tell me that? Which point? The answer is the point touching the curve, right? Which is the point touching the y square. So that means you will be using the concept of right minus left. You will be using the curve subtract the revolution axis, which is 0, which is you're using x equals to y square minus x equals to 0. That is inner because the curve is closer to the revolution axis. So you will be using the entire curve subtract the revolution axis. What about the outer radius? Outer radius. Which point or which curve is farther away from the revolution axis? The answer is the straight line, x equals to 2y. So you will be using the entire straight line, subtract the entire revolution axis, which is x equals to 2y minus x equals to 0. And then you do the outer square minus inner square. Okay, so overall, let's do the overall. The volume is equals to y goes from 0 to y equals to 2. And then, by the way, this one, if you factor out the pi, then you have a big R square minus small r square, right? So we go by that form. So we have pi outer square minus inner square and then dy. So let's prepare that outer square minus inner square. And then you fill in the blank y square minus 0, 2y minus 0. Keep the 0. I don't want to write a note that confuse myself, so that's why I keep the 0. So when I go back to my notes 2 days later, I know exactly what I did. Okay, so this is how you find the volume, but there is always a what if. People ask this all the time. The question is, okay, you rotate about the y-axis. Hey, what if I change that to something else? Hey, what if you rotate about x equals to 15? Hey, what if you rotate about x equals to negative 7? Can you do the what if for me? The answer is yes. So let's copy this graph over, and then I will do the what if for you. So let's copy, and then I bring the graph down here, and then I will do the what if for you. Okay, so let's erase the unnecessary y because that picks up the y as well. So the first what if. Okay, let's do a what if right here. So first what if I want to rotate here. Let's make the line bold. So what if I want to rotate about x equals to 15? Here, rotate about x equals to 15. That is my first what if. My second what if is, let's pick another number. Prefer to pick that on the left hand side of the y-axis. So let's say I want to rotate, how about x equals to negative 7. First of all, they are both vertical, right? The y-axis, the x equals to negative 7, the x equals to 15, they are vertical revolution axis, then they are both a dy problem. So let's do the 15 first. So go back to the 15. So for the 15, what needs to be changed? Do we change the 0 to 2? The answer is no. That is still from y equals to 0 to y equals to 2. What is the outer radius and the inner radius? So let's do the inner first, and then we do the outer. So the inner radius, look at the line in the area. Which point or which curve is closer to the 15? The answer is the yellow straight line, right? So since the yellow straight line is closer to the 15, then we will be using the yellow line minus 15, or I should use the 15 minus the yellow line. Answer my question. 15 minus the line or the line minus 15? The answer is we will be taking the 15 minus the line. Why? Right minus left. What is the distance between the 15 and the line? You take the bigger x, subtract the smaller x. The distance must be positive. That's why. So we will be using x equals to 15 minus x equals to 2y. So x equal. I am good. And then what about the outer radius? The outer radius will be the 15 minus the curve, right? So that will be a 15 minus the curve, y square. So we have x equals to 15 minus x equals to y square. You don't need to write all this little detail, but I am doing a lecture right now. When you do a lecture, I have to write out all the detail. Okay, we got all the ingredients. Let's do the work. So we have from y equals to 0 to y equals to 2, and then pi outer square 15 minus y square minus inner square 15 minus 2y square, close that, and then a dy. Outer square minus inner square. So that is the blue. X equals to 15. What about negative 7? You can quickly, if you wish, pause the video. Do that yourself. All right, so let's do that. So this is from x equals to, not x equal, keep writing x equal. That should be y equals to 0 to y equals to 2. That doesn't change the upper limit and lower limit. Where is the inner? And then where is the outer? Okay, which point is closer to the dashed line? Or which graph, which curve, or which line? So I can see that the curve, the y square, is closer to the negative 7, right? So I will be using right minus left. Then that will be y square minus negative 7. And this is x, to be specific, this is x equals to y square minus x equals to negative 7. And then the outer radius will be the yellow line. So that will be right minus left, 2y minus negative 7. So this is x equals to 2y minus x equals to negative 7, right minus left, because the length between the distance between them must be positive. And then the volume from y equals to 0 to y equals to 2, and then pi outer square minus inner square, 2y minus negative 7, do not simplify, minus y square minus negative 7 square, and then a dy. When I ask people to do setup but do not evaluate, that is exactly what I want. This is a calculus class. Everybody knows simplify, so you don't need to show me how good you are in simplifying this. So just show everything. Do not simplify. But if you are doing homework online, the systems might not accept this. Then in that case, you have to simplify. But on your homework paper, please have this. You are helping yourself. You're not helping me. You are helping yourself to understand the material. When you go back to this problem in the future, you know exactly what you did. You don't need to waste 30 minutes to find out what you did in the past. All right, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel if you haven't done so. Share the video for me. Appreciate your help and support to the channel. Signing out for now. See you all in the next video.